Hey everyone, this is lesson 7-2, Inverses of Relations and Functions. The objectives for this lesson, you'll be able to graph and recognize inverses of relations and functions, and you'll be able to find the inverses of functions. Your vocabulary for today, inverse relation, inverse function. You have seen the word inverse used in various ways. You know the additive inverse of 3 is -3, so 3 plus -3, you know, is 0. You know the multiplicative inverse of 5 is 1/5, so you know 5 times 1/5 is 1. You also know about the inverse matrix and how to use those. You can also find and apply inverses to relations and functions. To graph the inverse relation, you can reflect each point across the line y equals x. This is equivalent to switching the x and y values in each ordered pair of the relation. Remember, a relation is a set of ordered pairs. A function is a relation in which each x value has at most one y value paired with it. In example 1, the instructions tell us to graph the relation and connect the points. Then we're to graph the inverse. Then finally, identify the domain and range of each relation. So we're given this set of x and y's, and so let's graph them first. And so you see 0, 2, 1, 5, 5, 6, and 8, 9. Next, what we have to do is switch the x and y values in each ordered pair. So as you can see, the x has now become y. So here up above we had 0, 2, but now we have 2, 0. Here we had 1, 5, but now we have 5, 1, and so on. 5, 6 has been switched to 6, 5. So continuing with example 1, we need to reflect each point across the y equals x line. So let's talk about what that's going to look like. If y equals x, when x is 1, y is 1. And when x is 2, y is 2. When x is 3, y is 3, and so on. So there's our y equals x line. And next we have to reflect each of our points. So if our 2 is reflected across that, we end up here. Our next point comes here and down. So here's our reflections against across our y equals x. Now we could check our points to make sure when x is 0, when x is 2, y is 0, 5, 1, over 5 up 1, over 6 up 5, that works, and over 9 up 8. So you see that that all works. So now we can connect all of our points. There's our points in there. And now they are connected. And so let's talk about our domain. Let's talk about the blue set first, our first set. Our domain, which is our x's, they go from 0 to 8, all right? And the y's are going from 2 up to 9, all right? Notice that. Now, when we look at our inverse, the domain is 2 to 9. So our x's are going from 2 all the way to 9. And our range, which is our y's are starting at the 0 and going up to the 8. All right, so as you can see, the domain is inverse and becomes the range on our inverse function. And our domain on our inverse function is the same as our range on our original function. Here's one for you to try on your own. Turn the video off and give it a try. Okay, in this one, once again, we're going to start out and graph each ordered pair. Here they are. Let's see. Okay. So there's all of our points, and then we connect them together. Next, we're going to switch our x and y values. So now our 1, 0 becomes 0, 1, and so on. So now we're going to turn the page. Here's our we're going to reflect them across our y equals x line. And so let's go ahead. There's our y equal x. And when we reflect them, we see that they happen to be the exact same points on the other side of our y equals x line. draw them together, and so you can see what the reflection looks like. Again, notice that the domain and the range of the inverse are the same, and our domain and inverse are the same on the other set too. So notice how those work together. All right, when the relation is also a function, you can write the inverse of the function f of x as f negative 1x. Now notice this does not indicate reciprocal, and it doesn't even indicate an exponent. It's just a way of labeling so that you know the difference between the function and the inverse of the function. Functions that undo each other are called inverse functions. And what that means is the following. If I have a function, say f of x equals x plus 6, and I put in 3 for my x, so we know that 3 then plus 6 equals 9. All right, if these two functions are inverse of each other, I could put 9 in, and when I put 9 in, 9 minus 6 is equal to 3. The output is the same as my original input, okay? Notice our original input is also the opposite of each other. To find the inverse function, use the inverse operation. In the example above, 6 is added to x in f of x, so 6 is subtracted to find the function, inverse function of x. So take a look at example 2. It says use inverse operations to write the inverse of f of x. If f of x equals x minus 1/2. All right, so we notice that 1/2 is subtracted from the variable x. So what we should do is add 1/2 to x to write the inverse. So instead of having x minus 1/2, our inverse function is going to say x plus 1/2. We can check it. You could check by checking the input and the output. And as you can see, if I use 1 as my input, 1 minus 1/2 is the same as 1/2. So now I'm going to use 1/2 as my input. All right, and so when I use 1/2 as my input, I end up with 1 as my output. So that is the exact same as what I had. So that tells me my functions are inverse of each other. The inverse function does undo the original function. All right, try this one on your own. Use the inverse operation to write the inverse of f of x equals x over 3. All right, so on this one, it's not really that much difference. We notice that the variable x is divided by 3. So to undo that, or do the inverse, we're going to multiply 3 to write the inverse. So now you can see that the f of x inverse of x is equal to 3 times x. And you can check that again. We're going to use the input of 1 in there. So we can say if f of x equals x over 3, when we input 1 in, 1 over 3 is 1/3. So f of 1 is 1/3. So notice this is my input and this is my output. So now for my inverse, I'm going to take my output, which is 1/3, use that now for my input, and when I work it out, 3 times 1/3 is 1, and that is true. So that tells us the inverse function does undo the original function. Here's one for you to try on your own. Turn your video off and give it a try. Okay, so this one says use inverse operations to write the inverse. So notice that this was x plus 2/3, so it's pretty simple. 2/3 is added to the variable x, so now in order to find our inverse, we're just going to simply subtract. And then again, you could check. We could use 1 as input, and when you do that, our output is 5/3. All right, and so if we use 5/3 now as the input, multiply that together, we end up back at 1. So that tells us that the inverse function does undo the original function. Okay, so if we were to continue doing our inverses in this way, you would want to pay attention to this helpful hint. It says undo operations in the opposite order of the order of operations. So the reverse order of operations is what you would use. Now, we're not going to actually use this method that we just did very often, but if you were, you would want to add or subtract first, then multiply or divide, then do your exponents and parentheses. However, You can also find the inverse function by writing the original function with x and y switched and then solving for y. So this is going to be much easier for you. I don't think you'll have any problem at all. Okay, so let's look and see how easy this is to write and graph inverse functions. So the example says to graph this function, then write the inverse and graph again. Okay, so first of all, we're going to go ahead and set y equals to f of x, because remember we said y and f of x are the same. So I'm just going to say y equals -1/2 x minus 5. And so next I need to graph that, and I'm just going to sketch it out really simple over here. Okay, and let's remember what all of this means. When x is 0, y is -5. So I'm going to go 1, 2, 3, 4, 5. So when x is 0, y is -5. And this tells me my graph is negative, so it's going to be going this direction. All right, and my slope is rise 1, run 2. So I'm going to rise 1, run 2. Rise 1, run 2. Rise 1, run 2. All right, so here is what my first graph is going to look like, something like that. Okay, now I want to do the inverse of it now. So the next thing I need to do is go ahead and I'm going to switch my x and y's. So instead of saying y equals -1/2, I'm going to say x equals -1/2 y minus 5. Next, what I have to do is just solve for y. So I'm going to add 5 to both sides, plus 5. So I have x plus 5 equals -1/2 y. And still solving for y, I'm going to multiply both sides by -2. And when I do that, my 2's cross out here, so I end up with -2 x plus 5. Go ahead and distribute that, -2x plus -10. Equals y. All right, and then finally I want to write it back into y equals, so I'm going to say y equals -2x plus -10. All right, so let's just move this over to the next slide where I have a little more room. All right, so far here's what I have. My inverse is f of x now is -2x plus 5. And now we can graph it. Here was my original graph of when x was 0, y was -5. My new graph is going to be this one in red. And you can see that it's reflecting across the x-axis just fine, or this point y equals x. All right. So here's the one for you to try on your own. Turn your video off and give it a try. All right, so on this one, the very first thing we want to do is set it y equals. So we're going to say y equals 2/3 x plus 2. We're going to graph it. I'll do it over here really quick. When x equals 0, y equals 2. And we know this is going to rise 2, run 3. Rise 2, run 3. And so our graph is going to look something like this. All right, the next thing we want to do is switch our x and y's. So this time we're going to say x equals 2/3 y plus 2. So let's subtract 2 from both sides. So we have x minus 2 equals 2/3 y. Now to undo this 2/3, we're going to multiply both sides by 3/2. Okay, so I'm going to multiply 3/2 on this side and then switch my y's. Solve for y, which we just did. Now we're going to write it in that format. So we're going to these cross out. So we have y equals 3/2 times x minus 2. All right, and then we could distribute all that. And so here is our inverse function. All right, and then next we can just graph them both, and there they are. And that is the end of this video, and I just put a picture of the beach because that's where I wish I were today. The only thing missing from this photograph is me. Anyway, hope you guys are having a great day, and I'll see you in class. Bye.